Hi, my name is Dana Golden. Welcome back to Environmental Economics, and today we're going to be talking about finding environmental economic data. So you can get a lot of it from federal sources. The EPA has some great data on emissions and environmental quality. You should also look into data from the EIA on energy and energy markets. I have some really great data from the EIA. I'm looking right now at my wall where I have a huge and beautiful map of U.S. electricity and generation and transmission infrastructure. If you ever stop by, you'll get to see it. And it's all with EIA data. It's really just phenomenal data. ERAS and NAS have data on agricultural and rural environment, and NREL has data on the technical side and the potential of renewable energy. There's a lot of really good data for them on levelized cost of energy and levelized avoided cost of energy. In terms of private data sources, you have Bloomberg, NEF, S&P Capital IQ Global, and the ISOs. If you are a private sector commodities analyst who's working on energy, you really cannot be an analyst without having one of these two things. I cannot stress enough the importance. NEF, by the way, stands for New Energy Finance. The importance of having really, really great news and data to the job of being someone analyzing this industry. I used to work with a guy named Todd Hubbs, who was a commodity analyst on oilseeds, and he told me, Dana, we should be embarrassed that we don't have access to Oil World. You cannot be an oilseeds analyst without access to Oil World. And, I take that with me to this day. And I think you can't be a real energy analyst without access to one of these. So ISOs, the ISOs are independent civil operators, provide a lot of data on the electricity market and what's going on in the hour by hour, minute by 15 minute by 15 minute increment of the electricity market. You also have some international data sources if you're interested in more international data, like the UN, the EU, and the OECD. Most of these links work, or some of these links work, rather. Some of these links will take you to those places. They're hard to find regardless. So key data sources of commodity market data. Remember, the second half of the course is on natural resource economics and commodity markets. So you can get a lot from government or international organizations like the EIA, Energy Information Administration, we talked about even on the last slide. Energy prices, production, consumption data. U.S. Geospatial Services, data on metals, and this is the example of lithium data. I'm just going to take you to it real quick to just show you what it looks like. You can get old reports. I'm actually using some of these reports in a natural language processing project I'm working on. If anyone wants to do NLP for their final project, probably not a great choice in a 3-week course, but I would work with you to make it work. I really, I see, I want you to do real projects, and I want you to work with data, because I think showing people you know this data is how you get jobs in this industry. U.S. Department of Agriculture has NAS QuickStats, which has data on agricultural commodities. So we go here with NAS QuickStats. You go to the QuickStats tool. You can also access all of this data via API. ChatGPT has substantially lowered the cost of writing API calls, as I'll show you in just a moment. So yeah, just filter down. You can really get some really good data on agriculture and the rural environment right here. Really such great stuff if you are into that sort of thing. The World Bank commodity price data, historical price of key commodities globally, and of course, the International Energy Agency has really great expert analysis on energy market statistics and forecasts. Some honorable mentions that I didn't bring up here, but definitely exist. You can obviously check out OPEC. OPEC's been publishing some good reports and some good data series. And I've always found the EU natural gas reports to be pretty valuable. So I would encourage you, if you are interested in this sector long term, to reach out to me about what data here would be good to write a research paper on for this class. And then also I would encourage you to sign up for a newsletter from these agencies so that you can really stay up to date on what's going on and learn when the data are released. More commodity market data, obviously, once again, S&P Global Platts and Bloomberg Terminal, the two big players in the space, followed by, of course, Refinitiv, formerly Thomson Reuters, which provides commodity market data and analytics. All three of these are major providers of pricing analytics for commodities. You also have the Chicago Mercantile Exchange, the Intercontinental Exchange, and the London Metal Exchange. CME is really good with agricultural data. ICE has a great amount of energy data, and LME has some really great data on base metal prices. I would add the NYMEX, which is the New York Mercantile Exchange, which is a big provider of trading on metals. Maybe some of you know someone who works there, but the NYMEX is not really a great data provider. I've not been too happy with their data products lately. And yeah, there's some academic open data like Quandl and the UN Comtrade database, International Trade Statistics. Some of these are probably out of your price range. Like here, a lot of it's out of your price range. I can show you how to find some good open source and very cheap commodity market data if you're interested in that sort of thing. So now, in terms of accessing data, the way you used to access data is you went and found a Excel file. Yeah, assuming you didn't have access to databases, because that's its own thing. We'll talk about that a little bit later. But assuming you didn't have access to databases, you used to go and find an Excel file, and then once a month you would download that Excel file. You'd have it in a folder, and you would, just copy it into some database or into some other Excel file. Nowadays, most companies will expect you to know what an API is. API stands for Application Programming Interface. It allows applications to communicate with each other. It's how the web talks to, how the database talks to the web and how the web talks to itself. APIs provide a programmatic access to database via HTTP request, a hypertext transfer protocol language. So URL is where the API can be accessed, and then you add some parameters to customize the request, and then you use authentication methods. Here's a visual of an API. You have an application. That application makes a request. Usually the application, in our case, is going to be either Excel or R. You can do whatever you want. I can help you set this up with that software you're wanting, and then that goes to the data source, usually a database somewhere, and that responds with data. If you do it right, this is a very powerful tool. So steps to access data via API. Identify the API. Choose an API suitable for the data you need. Figure out who can provide you data, who has the data. I would encourage you to try to download a little bit of the data, like the normal way, to figure out exactly what columns you need and what parameters are helpful for you. Then obtain access. There are very few APIs. They're just completely open source. I used to work for the Department of Treasury, and we had an API that I don't think at the time really required much access because it was open source and had a very high rate limit. You should obtain API access, sign up for an account if required, and make sure to obtain the API key. Sometimes you have to pay for this. I wouldn't pay for this unless you have a very strong use case for the API. Often people overestimate how valuable an API key when they're first getting started. Make sure to understand the documentation, study the available endpoints, parameters, and response formats, and then make the request. Use tools like Python or Postman. Here's an example GET request to get some data. Parse the response, decode the JSON or Excel, and then store and save the data. That's the data format. So 99% of the code in this class is going to be in R. This is the only code I'm going to show you in Python. I was raised on Python. I still use it a lot. I think it's probably the best general purpose data language, but of course, R I think is pretty more standard in the department. And it's very good to know both, but I think a lot of you who came up on Python, so I just want to show it. So you import requests, you put in the base URL, you put in the parameters, and then you do response dot get, and then you put in the response. If the response status code equals 200, you do response.json to get the data. Else, you put an error. Normally, you try to do some other things with the processing of the data, and often, if you're doing this seriously, you'll be making a lot of API calls because you want to get a lot of data. So in R, you do a very similar thing. You download the library HTTR, download the library JSONLite. You use the URL here. It's the same fake URL. You use parameters with your API key. Obviously, replace this with your API key, and you replace the URL, your desired URL. You normally have some filtering mechanism like a date. You make a GET request. You have GET and then query equals parameters. And then if status underscore response equals 200, data equals from JSON, response equals text, print data, else, and then you want an error. So how to get an API from EIA? Visit the EIA developer portal, navigate to their EIA API registration, create an account, register with a valid email address, create a password, request an API key, secure your key, store it securely, treat it like a password, and do not share it publicly. And then use the API key to authenticate your queries to EIA endpoints. Steps for writing queries with EIA. Understand the documentation, read the official EIA API documentation, and know available endpoints, parameters, and data structure. Choose the right endpoint. Select the API endpoint that matches your data needs, electricity, petroleum, natural gas. Use filters, apply filters like geography, time, and series IDs to narrow down your data request. Test your query using Postman or curl. Optimize for efficiency. Avoid excessively large queries by limiting your data request. But what you need, remember, you have a limited amount. You can request in a standard time period. So use libraries from Python like time.sim to have it sleep for a little bit, and make sure you're managing your errors so that things don't break. If you're downloading a lot of data, you've got to figure out how to not mess with someone. They want to be able to download your data as long as you're not doing weird things and like running API queries constantly. So just write the API queries conscientiously. So example of an API query, fetch the total electricity generation data for 2023. You go to this website. If you go to this website, I don't think it's going to work because I think LaTeX has done something weird. But if you go to this website, as it actually is, it will get you, with your API key, of course, it will get you data electricity generation for this period. So you have a API key, you specify the type of data you want, you give the frequency, and you provide start and end. Then another valuable API to know is the PJM API. I'm a really big fan of PJM's data miner API. Just register an account, verify your email. It takes a little bit of time, but it's worth it. PJM has a remarkably good API that I've always found very enjoyable. It's called Data Miner, and you'll really have some fun with it. After log in, request access to the Data Miner API, and then obtain your API key. Stitch writing API queries, obviously review the documentation. Selected point movement endpoints, there's so much data there, you really want to understand, one, what it is, and then you want to understand what you need. So I recommend doing a few things. So first off, PJM, like EIA, has done something very nice where their API is very aligned with their website, so that essentially you just have to like write the query. You just have to do the query in their user interface and then copy that into Python or R as an API query key, and then of course rewrite it with a for loop to get all the data you want. PJM has a relatively low rate clip limit for non-members. It's never been an issue for me because it's been an issue for me, but I've never like downloaded enough that I couldn't find a way to work around it for the research I do. But yeah, PJM Data Miner, shout out to these guys. Really, really great data. So example, data miner query, retrieve real-time 5-minute locational marginal price for a specific date. Here's PJM's API. You can only get 5,000 at a time, so you want to loop through because there's going to be more than 5,000 for this period of a month because it's happening at 15-minute intervals. And they're in the PJM API, there are 4 different levels of granularity. You have a start row and a row count to find the pagination of results. You're going to have sort and order. You want to tell it how you want to sort and order it. You give it a date range and give it a format. I'm going to stop here before getting into tidyverse. I'm going to consider maybe later on adding additional lectures where I walk you through the PJM API. And obviously, if you come to my office hours, I would love to walk you through how to access data via API. I think this is one of the most useful skills for an economist that's not taught very often. Yeah, the last thing I'll say is it's a mistake to spend a lot of time writing API queries. Maybe do it a couple times so you know what one looks like. But in general, this is one of the best use cases of ChatGPT in coding. Well, this is a thing ChatGPT will do for you that can make your life easier. And, use an API. Get data programmatically. Don't go download spreadsheets. And with that, I hope you have a great day, and I hope to see you next video.